Hello, Mike Pennacchi here, and I am excited to be joined with Dan Klimke and Tim Titus. Dan's from NetAlly, and Tim is from PathSolutions. And today, the three of us are going to take a look at the challenge of remote site network management. And the focus of this is going to be on stopping fighting fires and start presenting them. So I'm going to go through a few things, few considerations that we need to take when we go in and start doing network monitoring, and especially where we're doing network monitoring of remote sites. And then we're going to move into Tim showing us what PathSolutions can do to provide monitoring, and Dan showing us what NetAlly can do with their tools as far as doing some of that network monitoring as well. So we're just going to go ahead and get rolling with this. And the big one is, why monitor? Well, oftentimes, and over the years, I've been out troubleshooting networks for the last 25 years. One of the things that I found is that network administrators, network managers tend to use their end users as smoke alarms. They wait until those end users call in and say, hey, we've got a problem, things are slow. They're not your smoke alarms. They are out there to get their jobs done, to earn money for the business. Your job is to figure out how the network's running, monitor it, and fix it before they even notice that there's a problem. And in order for us to determine what changed, because let me tell you, every time I've gone out to troubleshoot a network problem, it's been because something changed. So in order for us to know what changed, we have to know what normal looks like. And if we're not monitoring over time, if we're not developing a baseline, there is no way to know what normal is, so we can't tell if something's changed. Also, we need to know when new devices are added to the network, because what always happens is we run into an issue, we say, what changed? The person at the other end says, nothing. Really? Nothing. Really? Nothing. Really? Well, we added something. It's usually after the third time of asking. They will come back and tell you they added something. So if you know something got added ahead of time, then you can anticipate that. And then lastly, it's isolating the fault domain. All too often, when a problem occurs, we just run around and start trying to figure out everything that could have gone wrong, everything that we think could be an issue. But instead, what we need to do is we need to isolate that fault domain down. And the only way we can do that is by going in and knowing what's out there on our network. So what we're going to do is we're going to start with these network quadrants. And the network quadrants are a way of us going in and organizing how each of these different components of network monitoring fit in. So the first thing we're going to look at is how much of what and how fast. So what we're going to see is we're going to overlay these, because this is the type of thing we need to know. What does our utilization look like? What applications are running across out there, and are they running as fast as we expect them to? So here's our quadrant. In the lower left corner, we have usage. How's the network being used? In the upper right, we have time. And this is going to be our performance. What type of throughput are we getting? And for the most part, this covers everything that we care about when it comes to network monitoring and management. And that is the network being overutilized, and are we getting the throughput that we expect out of that? Now, what we can do in here is we can lay on top of that the different types of things that we collect. So if we start at the top, we have packets. I love capturing packets and looking at them. But you know what? I can't capture a lot of packets at 10 gig. I can capture a lot of packets at 10 gig, but my buffer is going to fill up and I can spend a lot of time looking at those. So I can't solve every problem by just capturing packets. We have active tests. Can we ping it? Yeah, we can ping it. But ping really doesn't tell us what our throughput is. It tells us I have connectivity. We have flow, and we're going to go through each one of these, but who's talking to whom? What are the conversations? What applications do I see out there? And if we come around over there to the left-hand side, we have stats. How's the network being used? So let's go in, and we're going to take a look at how some of the different monitoring tools fit in over the top of this. So we see that that lower left quadrant gives us how much of our network is being used. Then we have of what. So now we start moving into combining those counters with things like NetFlow. Tells us who's using it and what are they using. And then finally, if we move into that upper quadrant, that starts telling us what kind of performance are we getting? How fast is that running? Okay. So when we come in and we start taking a look at our different monitoring technologies, and as we're going along here, I'm just going to open up the questions window as well. Dan and Tim are both on the line. They're both able to see and answer the questions. So we're going to give some time at the end for answering these questions, but I just want to make sure that before we get too far in, start sending those questions in, and we'll do everything we can to get those answered. All right, so when it comes to monitoring technologies, some of the technologies we have out there are things like SNMP. Virtually every managed device on our network has an SNMP MIB. We can go in, we can query what are our interface statistics, what type of errors do we see. We have flow. So many of these devices are able to collect flow information. I see this IP address talking to this IP address on this TCP port, and it's sending this many bytes. So now I can get an idea of who is sending traffic and what traffic are they sending. We have our active tests. This is where I can start going in, doing pings, testing TCP port connectivity, doing throughput tests. And now we need to bring wireless into this as well. With wireless, we have our 2.4 and 5 gigahertz tests. So this is where I may start taking a look at my spectrum. What's happening out there in my 2.4 and 5 gigahertz spectrums? Do I see interference devices? Because these are going to impact my stats. I'm going to start seeing things like retransmissions, and it's going to impact things like my performance. Okay, so where does SNMP fit in on our quadrants? Well, if we come in here and we take a look, SNMP is on the stats side. SNMP is going to give us statistics about what's happening out there. It's not going to really tell us who's doing what, but it's going to tell us, do we see errors out there? Do we see what does our throughput look like? What ports are being used? Now, SNMP has been around for a long time. In fact, when I got into this whole business of monitoring and troubleshooting networks back in the early 90s, I was deploying SNMP probes, and we were monitoring the network, taking a look at the stats out there. So we see that SNMP was first proposed in 1988. Now, what it does is it goes out and it sends queries. So it does create a fair amount of network traffic itself, just monitoring, because it's constantly going, how you doing? How you doing? How you doing? So we're always seeing that traffic going out there, and we're querying devices, asking them how they're doing. We have 3 different flavors of SNMP. We have SNMP version 1. We have version 2, which allowed us to more efficiently pull the information off of there. And these two, if you've worked with them, the community strings are clear text. So not a lot of security there. This is where SNMP version 3 really came in, and that is it added encryption and authentication to that traffic. So now we can make sure that people are authenticated that are pulling that information. So what we see is SNMP is going to go out and grab statistics off of the machines out there or in devices on our network. So some of the useful information that we can get out of SNMP is utilization. What does my utilization look like out here? How busy are these links? Errors. Errors are a huge one. And I'll tell you, I've joked around, I've said, I can quit this business when I don't see duplex mismatches out there anymore. As much as we would love to see those disappear, people are still forcing ports to full duplex, causing issues out there. So this is where I want to be able to come in and find out which ports are having errors. Maybe you didn't clean the fiber before you plugged it in, but I want to be able to see what's going on. Bridge forwarding tables, I can see who's connected to each one of my switch ports, and this is where I can start building out a visualization of how my network's connected. ARP caches, route tables, all these come into play in building a picture of that network and how that network's running from a stats standpoint. Now, if we move down to the bottom of our quadrants here, we see flow. So flow moves beyond stats. Flow starts taking me into what conversations are occurring out there. And this is where we see technologies such as NetFlow, SFlow, JFlow, IPFix come in. for collecting that information. So in this case, devices like our routers, our layer 3 switches are collecting that flow information and passing that to a device. So in this case, this allows our IP conversation information to be collected and analyzed. NetFlow, we see, was introduced by Cisco for doing this within their equipment, and we've seen some other vendors, try and roll those sort of things in as well. There's 3 components to this, and that is that we have our flow exporter, so it aggregates the packets into flow. So this would be something like my router. It sends that to a flow collector, and that flow collector is going to start taking all those flows and putting those together into a single database, into a single collection of data. And then we have a flow analyzer, and that flow analyzer's job is to make sense of that traffic. So now, if I see my utilization go up on my SNMP statistics, I can go over to my flow and I can find out who is talking, what application are they running, and is that an application that I want to see out there on my network? So where does flow fit in? It gives us our stats, but flow gives us information about why we're seeing those stats jump up. Okay. Packet capture. This is, again, one that I love. I love capturing packets. I love getting in there and getting into the nitty-gritty of what's going on with our network. So packet capture, sometimes just looking at the conversations isn't going to solve the problem. Just looking at who's talking to whom isn't going to solve it. In those cases, what I need to do is I need to get in there and I need to see who is talking and are they following the protocols. That's why my company's network protocol specialist, my job is to go in and find out, are they talking like they should? Are they doing what they should out there? But it becomes tricky with packet capture. I have to be in the path of the packets. Well, with SNMP, I could have a device located back at my central data center collecting statistics throughout my entire organization, and I could have flow devices all sending data back to that data center. With packet capture, I have to capture the right packets. I have to capture all the packets without loss. I have to be in the right place at the right time. And I need a way to go in and analyze that traffic and figure out what's going on. So packet capture can help us get those deep down problems that we can't solve any other way, but it's more intensive as far as being able to go in and do that. So then that takes us to our device service performance. And this is where we start doing our active tests. This is where I can start doing pings. I can start testing TCP ports to see, what's happening out here as far as, am I able to connect to the TCP ports on the servers I need to connect to? Am I able to follow a path from one end of my network to another? So my active tests are going to tell me, are the services available that I need to get my job done? So in this case, we can go in, we could do ping, we could do TCP port open, we could even create complicated synthetic transactions that are going to give us what those connectivity response times are. How long did it take to resolve DNS? How long did it take to establish a TCP connection, get the first byte back? How long did those take? We can go in and take a look at those. We can also start going in and doing things like bandwidth testing. Now, we're not going to get into it with this presentation, but when it comes to bandwidth testing, one of the things that we always like to look at is full line rate versus application. That's one that's good for another presentation, okay? And then we have 2.4 and 5 gigahertz, which really kind of fits in the middle. Now we need to start taking a look at interferers. What does our utilization look like on our wireless channels? Can we connect to the network? What type of conversations are going on out there? So hopefully mapping these different technologies over these quadrants show you that these are non-overlapping technologies, that we have to have a little bit of all of them to be able to get a comprehensive view of what's going on with our network. So 2.4, we need to take a look at interference sources. We need to know what could be impacting our network so that we can make sure that that network is clean and we're able to get that information across it. Okay. So this takes us to location independent versus location dependent testing. So we've talked about the quadrants and the testing we can do. So now we're going to divide this up a little bit, and we are going to take a look at which of these technologies, what do we need to do that we can do from anywhere within our network, and what has to be specific to those sites we're at. So location independent. This is where we're doing monitoring from a central site. I put in a monitoring server, I let it scan all my networks, it discovers what's out there, and then it starts monitoring it. This is perfect for long-term monitoring and utilization, error and utilization monitoring. I need this in my network. If I use my handheld tool for just doing this, every time I move the handheld tool, I lose those long-term trends. So this is a critical component to being able to get an idea of what's going out there. Now, the tradition has been we are monitoring servers. That's great. But we see a lot of the servers are moving to the cloud, but the network isn't. We still need a transport mechanism to get us out there. So in this case, we always need to be able to answer that question. What happened last Friday at 3 o'clock? We need that long-term monitoring, and that is very well done from a centralized location. So this helps us develop a baseline. We can start taking a look at how that baseline changes. What do we see? Do we see a spike in utilization? If we do, who's talking? What's going on? But if we're going to do this monitoring, we need both depth and breadth of monitoring. We need to be able to get a good picture of everything that's out there and really drill into those counters to start seeing what's happening. So where does this fit in? Stats and flow. This is where we can start hitting these counters as far as our SNMP counters, our error counters, our conversations, our packet counts. Location dependent. This is where we start getting into wireless, packet capture, layer 2 discovery, network validation. These are things that can only be done out at that location. So part of that is validation. Now, I'm going to say this very quickly because my portion of the time is almost done here. And that is, I spent about 5 years as a volunteer firefighter when I lived up by Yosemite. And what I found is people love firefighters. We'd show up at somebody's house with a 2.5-inch hose line and dump 250 gallons a minute of water into their living room, and they would be applauding us. But if I was a fire marshal, they hated me because I was coming in telling them how to keep their house from catching on fire. This is what I need you to do. This is how you stop fighting so many fires. So you start doing things like validation. You start developing a baseline of what that looks like, or what your traffic looks like on your network. So when it comes to wireless validation, out there at that site, we need to know what our signal level is. We need to know our noise. We need to know our location dependent connectivity. I need to know if there are interferers, and I need to know what my throughput looks like on my wireless network. From a wired validation standpoint, this is where I need to go in and map switch wall jacks to switch ports. And what we're going to see is we can roll all that documentation up into a website. So now we can come in, and if somebody says I'm out at this location, what port am I connected to? I can pull that up immediately. And I can validate that I'm getting the PoE that I need, the speed and duplex and the connectivity. Also that I'm getting DNS and DHCP, as well as server connectivity out there. So these are things that need to be done from a location dependent standpoint. So where do these fit in? Well, this is where I may have to do packet capture for wired and wireless. This is where I can do my active testing. I can do my throughput testing out there. I can't do throughput testing from a central location without something out there at the remote end. So that takes us through that portion of it as far as an introduction. So I've set the stage here as far as what we've got going on. So what I'd like to do is turn it over to Tim Titus with PathSolutions, and Tim is going to help us get an idea of what they have to help us address this, because what we see out of the presentation I just did, there is no single tool that's going to hit all those quadrants. So Tim, take it away.
Thanks, Mike. I got to talk to you more about your fireman story. That sounds very interesting. One thing I want to start talking about is that really with what NetAlly does and what we do, I think everyone's going to see how the two products pair together in the exact quadrants that you spoke about. Our solution is focused on root cause troubleshooting, of collecting information on using SNMP, using NetFlow, and I'm going to show you how we do this and how we're different than other products on the market. This is going to go very rapidly, and then we're going to show this is how we hand off to an EtherScope to be able to say this is where you'd pair with an EtherScope to be able to do that type of troubleshooting. So let's dive in really quick. So what we do that's different is we're going to deploy on a single server. With our collection and monitoring, one of the things we do is we automate this. There's a high degree of automation, meaning we deploy and really within minutes, we're going to have every interface, every switch, every router automatically monitored. That means nothing is left out. This is a problem for a lot of other tools, is that you might not have all of the ports monitored. You're responsible for every interface. You're responsible for every device. We've architected this so that you're going to get total network visibility into every one of those interfaces, every one of those devices. And we collect this information every 5 minutes. That way, if any problems happen at any point in time, you're going to be able to help answer that question Mike asked, is what happened at? If somebody says, what happened at 2:35 in the afternoon, you're going to be able to answer that question because you know what the entire infrastructure was doing at that point in time. Additionally, though, we're going to go far deeper than any other monitoring package. A lot of other monitoring software might collect 1, maybe 2 error counters on the monitored interfaces it has. That leaves a lot out of your view. So we figured we're going to go collect the performance, the configuration, 19 different error counters, all the QoS, CDP, LLDP, PoE, what's connected. With all of that information automatically collected on every interface of the network, what this means is you're going to know your network to a far broader and deeper level than with any other product. That means that the mysteries that exist in your network are going to be exposed. The trick about this is that your switches and routers, they know all about this stuff. They know that there's a problem with a duplex mismatch on this interface. They know about the microburst link flood. They know about the backplane overutilization, QoS misconfigurations, spanning tree topology changes. All of these things are trapped up inside your switches and routers. We figure if we automate the collection of this information, bring it back, and then put a plain English heuristics engine on top of this, that means you're going to get these plain English answers saying, here's what's broken in your network so that you can start to fix them. So with a single integrated package, we can do network diagramming because we have routing tables, bridge tables, ARP cache, spanning tree, path mapping capability, port mapping, server monitoring, all of these capabilities built into a single solution that has a far higher degree of automation and deeper and broader understanding of your network, meaning you're going to know more about what's going on than with any other solution. Now, if you're interested in playing around with this, we've set up a sandbox. So you can just go to www.pathsolutions.com/sandbox and be able to take a look at this yourself. Let's dive in and do some sample reports. So you come into the network and say, let's see what's going on. You can go to the network tab. You can end up looking at our network map, and this will show a live look into links and devices and remote offices so that you can see what's happening in a live context. This updates every 5 seconds. That way, when an outage occurs, you know about that within seconds. We have an automatically generated network diagram. So if you want to see how your network is laid out, this is going to automatically show you all of the subnets, all of the devices. If you want to change how this network displays, you can move elements around. You can also lock elements in place. If you're curious to wonder, what the heck is the 86 subnet? What's its purpose? 10.86. It's going to find it, put it right in the middle, and say, that connects the Syrah switch to the firewall. You now know that's the point-to-point that connects those two. So searching for devices and elements in your network is real easy. Well, let's go into a sample root cause troubleshoot. So I'm going to go into the Devices tab, and these are all the switches, routers, gateways in the entire infrastructure. We notice there's a red dot in front of the Syrah switch. We can click into that switch, and we're going to see all of the interfaces on that switch. We see interface 5 have a red dot and 4% packet loss. Now, if I told you, hey, we found packet loss on a switch port, most people would say, should I even care about that? If it's a printer or a photocopier, that's a low priority problem. But if this is somebody's VoIP handset, or this is a trunk port to another switch, or it's a default gateway, that's a high priority problem. So depending upon what's connected drives the criticality of the fix. So to help answer what's connected, we expose all of the CDP and LLDP information for that interface and all the interfaces. We also have a fully integrated port mapper. Click on the Connected tab, and we're going to tell you that interface has one MAC address. That MAC address associates with the HQ Voice VLAN, VLAN number 110 in our environment. We have the MAC address, we have the manufacturer, we have the reverse DNS, and we realize this is our voicemail recording server. So packet loss on this interface is going to create choppy voicemails. Okay, this is a high priority problem. Let's go see what the problem is. We click into the interface, we're going to see the utilization graph, we're going to see the packet loss graph. And then below that, we have the network prescription. Here, we're being given a plain English prescription of what the problem is. In this case, we're being told that it's a cabling fault. So it's that fast and easy to detect that we have a problem on the Syrah switch, a problem on interface 5. It relates to packet loss. It affects this voicemail server. Here's when the problem started, here's when the problem stopped, and here's what the problem is. Now, how is it that we can detect a cabling fault, yet many other monitoring packages might not even be aware of this problem? The difference is that we're going deep. You click on View Error Counters, and it's going to show you all 19 of the error counters we're picking up on this interface. Other products might only look at inbound errors and outbound errors, and it's going to say, hey, this is a healthy interface. We're going to say, actually, it's not healthy because we're seeing a ton of FCS errors. There's some deferred transmissions, some outbound discards. And what our heuristics engine does is it analyzes the presence and absence of these error counters and the configuration to come up with a plain English prescription telling you you're looking at a cabling fault. That way you don't have to crack open the books and try and determine what does it mean when you have FCS errors and no alignment errors on the interface at the same time. We're going to tell you it's a cabling fault. If you want to learn more about these error counters, we have a built-in engineer's library. Click on the error counter. It's going to show you the official IEEE definition, a more basic lay definition, and then what you should do to fix the problem. And it goes through all of the different causes as to where the problem can come from. So something to recognize is that with all of these error counters collected on every interface of the network, what that means is any single packet dropped or buffered anywhere in the network, any point in time, we know about it. That way, you can have far better awareness about your environment than with any other product. Basically, what we're doing is we're telling you, here's what the network equipment knows that you should know. So let's do a root cause troubleshoot between a pair of IP addresses. If I go to the Path tab and say, we have a user who was on a PC and they were connecting to a gateway in a remote office. We can put those two IP addresses in and click Map. This is going to show every link, every switch, every router used to connect these two devices across the network. Now, let's say our user complained about a problem that happened right before noon. So let's diagnose this. Here's their PC. Looks like it was plugged into the Pino switch connected to interface number 7. That interface looks like it's perfectly healthy. Now, Our definition of perfectly healthy means perfectly healthy according to all 19 error counters. So we can be confident that the interface actually is healthy. Again, other products, if they're not looking at that many error counters, you might have collisions, and the interface is going to say it's healthy according to the other product because it's not looking at enough error counters. So you can have confidence this is actually a healthy interface. It's going out interface 25, and we see that right around noon, there was some utilization, but there's more bandwidth available, and there's no packet loss. So that's a healthy interface. We're going inbound and outbound on the Syrah switch. That looks good. Okay, looks like outbound on the Burgundy switch, going out interface number 3, we're seeing that right before noon, we were dropping 6% of the packets. I think we found a suspicious interface because this matches with what the user was complaining about at that time, and this is the interface that was dropping a bunch of packets. Now, before I dig in to see what's going on with this interface, we're going to do a quick check to see if there are other problems. Because because we found one interface with a problem doesn't mean we should abandon our searching. We can see that the next interface is the Santa Clara router. We're dropping a little bit of packets there. Looks like it's running half duplex. Okay, that's a quick, easy fix. We can see that the outbound interface on that router is running class-based QoS, and there's a high priority voice queue and a default queue. Gee, this is bad. The high priority voice queue isn't taking any traffic, so we need to investigate that as well. So we have a couple of things that we've already detected here. Let's start researching the first one. So this interface number 3, I'm going to click in here to see what's going on. As we click in, we see when the packet loss started, when the packet loss stopped, and we see the network prescription. Here it looks like we have some deferred transmissions, collisions, and frame too longs that are saying, looks like we have a VLAN tagging issue. So we have a number of clues here saying we've got a problem. Now, the VLAN tagging issue is something that we can't necessarily diagnose from the network's perspective, and so that's really where you'd want to end up plugging in an EtherScope to be able to do that next step of troubleshooting. So at this point, I'm going to do a handoff to Mr. Dan Klimke.
All right, thanks, Tim. Yeah, let me get my screen going up here. There we go. All right, so let's get into what it means to take a look at the network from a location-dependent point of view. And just a reminder of what Mike was talking about here, we're talking about diagnostics that are occurring from the point of view of the user in the network, whether that's a wired connection to the network or a wireless connection from the network. And again, what we're trying to touch on here is there really is no single ultimate tool in and of itself that is going to give you every perspective you're going to need to manage and solve problems on your network. The quadrants that Mike talked about the different data sources and how really we need a combination of those data sources in order to do appropriate diagnostics as well as validation and monitoring and management of our network. But as we've observed over time, a lot of us in the network professional business, we tend to like having a lot of tools. And we often will find that one of our tools may have a gap, and so we'll go get another tool to solve and fill that gap. And ultimately you end up with a big collection of tools where typically in many network operations departments, too many tools for any one person to know how to use all of them. I remember one time visiting a large healthcare provider down in the Houston, Texas area. They had a pretty decent sized network operations team, about 6-7 people. And each one of them had an area of specialty in terms of the kind of tool that they primarily supported. You know, John was the NetFlow person, and Bob, he was the NetAlly tool person. And what ended up happening was that problems would get bounced around from person to person to gather that independent perspective. So I think that the answer there, and we'll probably touch on this at the end of the presentation, is we want to have all of those perspectives in as few tools as possible. So let's get into that. location-dependent information, again, it's diagnostics from the user's perspective. That's testing network services and user response time and discovering the network from the point of view of the user. It's absolutely essential to have a centralized monitoring service like TotalView from PathSolutions, but that's taking a perspective from that central location. And that's what gives you your long-term monitoring of those statistics. But out at the site where the user is, oftentimes there are going to be problems like Tim was suggesting around a VLAN that cannot be identified from that central location. So that's why this combination of location dependent and location independent metrics and diagnostics are necessary. So I'm going to talk primarily about the EtherScope NXG. This is a product that NetAlly came out with just last fall, really the flagship of our product line because it embeds all of our technology that we've learned about doing network analysis in portable tools since our company effectively started back in 1993 when we were a part of Fluke Networks Incorporated and have morphed over time and have become NetAlly as of last year. So EtherScope is a multi-technology tool. We don't cover off all 4 of those quadrants in terms of packets and flow and active testing and stats, but we cover off on 3. So EtherScope utilizes SNMP, utilizes active testing, and utilizes active analysis of the packet flow in order to give you as best of a perspective as you can possibly get from where you're connected wired or wirelessly out in the access layer of the network. So Mike talked about this a little bit, the need to validate. We talk about trying to add some proactivity to our lives as opposed to being stuck in firefighting mode. And one way we can do that is to proactively go out and validate connections when we do adds, moves, and changes or new installations. EtherScope's claim to fame is this auto test, the ability to conduct, and this is really no exaggeration, it can be up to an hour's worth of testing if you had to utilize a large tool bag of tools in order to get all of this data in just a few minutes. And this includes validating link. And first off is regarding power over Ethernet, fully loading that link. Not just did the switch tell me what the port configuration is, but actually drawing a load from that switch to see if we can get full power at the powered device. And this is something you can only do if you're attaching a device on the end of the cable and applying that load test. Ethernet link characteristics and cable testing. What is actually happening on the wire? Am I getting full duplex? Am I getting the speed that I expect? Or is there an issue on the cable itself? Next up, what's my nearest switch? Where am I connected? What VLAN am I connected to? Or if I'm on a trunk port, what VLANs could I connect to? And then validating network services like DHCP, DNS. Can I hit my default gateway? Can I get out to the internet? Let me drill in one bit here on a new capability that we just released for EtherScope, and that's the ability to do a signal to noise ratio or SNR test for multi-gig. Now, we all know that multi-gig is speeds greater than 1 gig out to the access layer, primarily been developed to provide greater bandwidth for access points that are delivering higher rates of speed. So we're trying to get more bandwidth out of our existing cable plant. And this SNR Cable Test actually is looking at signal to noise ratio on that cable plant and warns us if we have a measurement that's out of spec. Now, many times, and what we're hearing from many customers who've deployed multi-gig, they're not getting the enhanced speeds that they are expecting. And that can be caused by a number of different kinds of faults in the cabling. You might be able to link, but you might not link at the speed that you're getting. So this is the kind of test that you have to be able to conduct from that connection in order to test. Can't be seen from a central point of view. We also want to be able to have a view into the network performance and the end user response time. That is, what's the response, what's the ability to transfer packets over the network to my actual user's point of view. So this is looking at the performance factor, how fast. So by decoding, for example, going out to a website like Google and taking a look at, well, how fast could we ping that site? Well, ping is ICMP protocol, and maybe it passes, maybe it doesn't. How fast can we do a DNS lookup? How fast is the TCP connection? How long does it take for the data to start, the data flow to start, and then how long does it take to transfer the data? This gives us a perspective of how fast the network is performing. We know that the network itself at the network layer is pretty darn fast, but if the user's having performance issues with a specific server or application or site, we'll be able to decode that from that point of view of the user. Now, this auto test that we talk about can also be run in what we call now periodic mode. And again, a new capability that we just released allows the user to configure this test to run multiple times. Envision that this is kind of like taking multiple snapshots over a period of time and then trending the results. So we can get information, again, from the point of view of that user into the network trended over time. Now, EtherScope does not sit on a server. It sits in the palm of your hand, and it's not built to take these kinds of measurements for days or weeks or months like a solutions like TotalView from PathSolutions is. That's meant to collect that trended data over a long period of time. EtherScope does this for the purpose of troubleshooting. I've got an intermittent issue. I need to test a certain number of diagnostics over a period of time, and I want to know when any of those diagnostics go off the rails. And so that's why we enable problem notification, so that if any one of these metrics shows off some sort of error, you can be notified that they're happening. And then to be able to have the background and the details to drill in. And Mike also mentioned what in and of itself is a whole nother webcast itself, is actually doing performance testing. Now, what performance testing is the ability to inject traffic on a link and measure it at the far end. So in this case, two EtherScopes could be utilized together to send traffic up and downstream in the network. That way we can characterize the total capacity of the network in terms of bandwidth, identify how many frames are lost, we can identify latency and jitter, and we can also validate QoS. So this is the ability, again, packet-based testing, active testing, pushing traffic on the wire at up to full 10 gig speeds, or layering in a small amount of traffic in order to characterize the capability of a particular link, such as from one site to another, to be able to validate your service provider SLAs, or to be able to validate how much bandwidth you actually have, or that you're maintaining QoS from end to end. So that's another key characteristic of needing to be able to have packet level visibility in this way by actually simulating traffic on your network. And then there's a whole host of network health assessments that can be done. Certainly on the Wi-Fi side, you've got Wi-Fi air quality testing to be done. How well utilized or poorly utilized is my Wi-Fi network? Do I have overlap in my channels? Do I have neighbor networks that are interfering? What devices are out there at certain connection speeds? Can I automatically detect some problems like, hey, one of my BSS IDs is changing channels left and right. Maybe I have an adjacent network that's causing problems for my network. And then an integrated tool set and workflow so that we can go from this discovery to path analysis. Again, being able to utilize information gathered by way of SNMP from the point of the user to see what is my path from where I'm connected out to a switch, going up to my router and on throughout my network in order to help troubleshoot what's the path that the packets are taking from this point of view. And then, of course, as Mike mentioned, what he loves to do is capturing packets. In case you get to that point where we absolutely have to have the evidence, we absolutely have to have a trace file in order to prove something to someone else, or get down to the inter-packet behavior to determine why is a particular behavior occurring. And so EtherScope gives you that capability to do wired capture or wireless capture. Wired is up to line rate at 10 gig, so you can be assured that you will get the right packets and not lose any packets, and have everything needed for analysis. And then just obviously the ability, the ultimate in location-based data is indeed what's happening on the Wi-Fi network. And another capability that we just released recently was this AirMapper site survey app, the ability to conduct a site survey using your EtherScope to collect site data that's localized to a particular sample point, and then the ability to generate heat maps in order to diagnose problems on your network or to validate adds, moves, and changes of your Wi-Fi network. Absolutely the simplest, fastest, easiest way to do a site survey on your network. That's it. So we've run through a little bit more time than we wanted to, but we still have some time for some questions. Mike and Tim, I'll ask you guys to go ahead and come off your mute if you haven't already. And I do notice that we've got a couple of questions already. First one, Tim, it sounds like you answered this by your comment in the Q&A window, but how about you go ahead and talk through your answer to how is PathSolutions different from another product, say like SolarWinds?
Yeah, so specifically SolarWinds is designed to monitor a few interfaces on a few devices in your infrastructure. And also it has 2 error counters that it collects. And so the problem is that if those 2 error counters show 0 on the few interfaces that you're monitoring, you're going to have somebody say, hey, my network is healthy. Why are we having call quality problems? And therefore you're going to say, well, it must be the phone system. It must be outside of the network because this network is running clean. The truth of the matter is, you could have SolarWinds and have, just like what Mike was talking about earlier, is you could have a duplex mismatch, and SolarWinds isn't going to be aware of that. And so it's not really going to get you that root cause visibility into where are you dropping packets, why are you dropping packets, and it's partially as it doesn't go broad enough and it doesn't go deep enough to give you that complete picture. It also, even if you did go through and say, gee, I'll spend a few weeks of effort or maybe months, depending upon the size of your network, to try and configure it to collect more error counters on more interfaces, you then still have to interpret what does it mean when you have FCS errors and no alignment errors on the interface, or if you have FCS errors with alignment errors and no collisions. And so doing that interpretation also means that you're left scratching your head and having to hit the books to try and understand, whereas we're just going to tell you, yeah, you're on the full duplex side of a duplex mismatch based upon how these error counters present. Thus, you're going to identify and get the problem resolved a lot faster.
Great, thanks, Tim. And then there was another question too about SD-WAN.
So we do have an SD-WAN monitoring capability that will track each individual carrier individually. That way, if you end up having an SD-WAN failover and you're wondering, why did the controller do this? We're going to be able to tell you, oh, it was 6 hops in and it was a route path change that had a huge amount of latency. Therefore, you're able to identify what caused that SD-WAN failover so that you can start determining, hey, this one carrier is just notorious for having a problem on this router. If I can alert them of that, hopefully they can get that fixed.
Is there any limit to the number of interfaces you're monitoring?
So we scale up on a single machine. You can scale up to 200,000 interfaces, 200,000 ports. So some really large deployments. We can do 150,000 if you give us a virtual machine. So even in a virtualized environment, we can have some large deployments.
Cool. That's a lot. That's a pretty good scale up.
Yeah.
Mike, any last thoughts here? And if there's any other questions, folks, please feel free to send them in. But like I said, I was hoping that this discussion about those quadrants helps illustrate the kind of data that we need to be both proactive and reactive, and that the more we can do on the proactive side, number one, having a monitoring tool like PathSolutions in place helps us be proactive, but then also having some proactivity in terms of our workflows, the kind of validation testing whenever we do adds, moves, and changes with EtherScope. Any last thoughts about that, Mike?
Well, I think that in addition to having the location independent monitoring centrally, with tools like the NetAlly tools where you can operate them so easily remotely that we can use that as a way to give us that location dependent information and still not have to travel out there. And I think right now that becomes such an important piece. And the whole link live ability to upload that information you discovered. So for instance, here where I'm presenting from, I've got total view from PathSolutions up on my screen watching my network. But at the same time, I could remote into Link Live and connect right into the EtherScope NXG, and I could drive that. So now I've got a Pelican case I put together. I could throw that in a case, overnight it out to a site, and now I could start getting that location dependent information. So I think it's important to note, location dependent doesn't mean you have to be at that location. We need a test tool at that location. So you're remoted in there to a EtherScope NXG. So now I could have these deployed at different locations. And I mean, I know, Dan, you focused on the EtherScope. As far as collecting validation information, I mean, we can get all the way down to the link sprinter as well to get that validation and location dependent information. So I think that for me, that combination, what can you do? So for everyone that's on the presentation, please think about those quadrants and how do the tools you have today fit into those quadrants? Are they doing a good job of covering those quadrants? And do you have any gaps in there? Because if you do, those are places that you can't see into your network. So focus on filling in all those quadrants.
Outstanding. Well, folks, we're just about at the top of the hour. I want to thank you for your time and attention this morning. I hope you found today's presentation useful. This presentation has been recorded and will be posted. Probably both ourselves at NetAlly and Tim at PathSolutions will post links on our mutual sites to it. So if you want to go back into it or share it with someone else, it'll be there for you. And of course, you've got our contact information there. Feel free to reach out to us if you have questions afterwards. And Mike, Tim, thank you so much for joining us on the call today.
Thank you, Dan. Thank you, Mike.
You bet. Have a great day, everybody. Cheers.
Stay safe.